Question number 1. Assume that number 1 there is a lower value, higher value 58, lower value 5, Q1 first quartile is 21, Q3 is 36, the median is 28. Now we need to draw a box plot. So we have the stuff to draw the box plot. Now this is 0, this is 10, 20, 30, 40, 50, so this is 60. So this is going to be the middle line. Now lower value, so lower value is 5 here, so this value is 5. And then first quartile 21, this is 20, 21 here, so this is 21. Then third quartile to 36, somewhere here, so this is 36. And the other one is Q2 28, 28 somewhere here, so then this is going to be like this, and we'll make the box and we'll delete this line. So you can draw up to this one and then this point onwards. The maximum value is 58, so this is 50, this is 60, 58 is here, so this is the point. So those are the whiskers and the box. Yeah, we done the box plot now. And question number 2, write down the upper and the lower quartile. So when you look at the graph, you can see that upper is going to be, the lower is going to be 32, and they are marks, and upper is going to be 47. So Q1 is 32 and Q3 is 47. Part B, write down the median. The median we can see at in Q2, or median we can see at 38. And part C, IQR, interquartile range minus Q3 minus Q1, 47 minus 32 equal, that is going to be 15. And part D, range, max value minus minimum value. The maximum value you can find, that is 76, minus minimum value is 12, so range 64. Question number 3. Male and female turtles. So compare, part A, compare and contrast the mass of the male and female turtles. So we can look at Q1 male is greater than Q1 female. Q2 male is greater than Q2 female. Q3 male is greater than Q3 female. And IQR for male is greater than IQR for female. And what else? range range for male, range of male is greater than range of female. Right, fee actually more sensible. Female. Yeah, those are the things we can say. And part B, question part B. That's a good question. If a turtle, a turtle was found out to have a mass of 330. So a turtle was found out. The weight is 330 grams. So whether it is male or female, what is the possibility? So when I look at with the graph, I can see 330 somewhere here, 330. When I draw this one, I can see that it is in this IQR of female. So because of that, so there is a more possibility. It's like to become a female turtle. Uh, it is more likely to be a female turtle. Also, we can tell that very few male turtle weigh about 330. Further, we can tell that uh, the amount is just before third quartile of female. The amount is just before the third quartiles of uh, female, female, approximately 3/4 of females uh, turtles are below 330 grams. If you want, you can add more, bit more here. The value lies in the IQR of female. Hence, it is more likely to be a female turtle. So the part C, write down the size of the largest female turtle. When you look at the data set, so you have to get the largest. It doesn't matter it is outlier or not, the largest. So largest is 500 grams. You can see that data point as an outlier. Question number 4. We want to calculate first quartile, second quartile, and third quartile. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There are 25 data. So n equal 25. So we want n q1. We want find n divided by 4. 25 divided by 4. This is going to be 6. 0.25, round up. This is going to be seventh term. What is seventh term? So this is in the ascending order. This is the ascending order. 13, 17, 19, 20. So seventh term. 1, 2. So up to here 5, 6, 7. It is 22nd. So Q1 is 22nd. And Q2 is n divided by 2. That is 25, 2. This is 2 times 6, 25. 12.5, round up. 13th term. So what is the 13th term? This is 5, 10, 11, 12, 13. It's going to be 26. And Q3, n divided by 4 multiplied by 3. 20 divided by 4, 4, 3, 6, 12.5 times plus 8.75, round up. That is going to be 19th term. So this is Q3. Up to here it is 30. When you take 1 away, 19th term is 30. Now, now we want to find the outliers. To find the outliers, so we want to get IQR first of all. What is IQR? IQR is 30 minus 22. So that is going to be 8. Then we'll calculate upper bound. We want to add Q1 plus 1.5 times 8. Q1, Q3 plus, not Q1, Q3 plus 1.5 times IQR, which is Q3 is 30 plus 1.5 times 8. So this value is going to be 42. And lower bound, Q1 minus 1.5 times IQR. So this is going to be 22 minus 1.5 times 8, that is 10. So now so this is the range now, 10 to 42. So any value below 10 or over 10, over 42 is outlier. So minimum value is 13. So there is no minimum outlier. Let's see, go the other side, 42. So there are two outliers I can see, 46 and 78 greater than 42, 46 greater than 42, and 78 greater than 42. Hence, they are two outliers. They are 46 and 78. Now other one is we want to draw the box plot. Now take the outliers out. When you get outliers out, this is the data set. Now what is the minimum value? Minimum is 13. Maximum is 38. So we can draw now. So this is going to be Q1. What is the Q1 value is going to be 22, and this is going to be 30. Q2 is going to be 26. So this is 26. And minimum value is 13. And this maximum value is 38. and two outliers. One is 46, so this is 46, other one is 78. So this is the box plot, but these scales are not right. You can draw to a proper scales, but those are the uh, values you should appear on those ends. 13, this one 22 first, this is 26, and then 30, and this the whiskers in upper bound is 38, and 46 outlier, 78 outlier. Now my last question for addition for this sum is, what is the range? When you find the range, you have to consider whole data set. Not we separate this data set to draw the box plot, but when you take the range, it should be whole. It means maximum minus minimum. Maximum is 78, minimum is 13. So range is 78 minus 38. So 8 minus 3, 5, and 7, 1 is 6.